All right, y'all. So today in math, we're covering common logs. You guys already did this right before I came in. But one thing I noticed when we were working on this problem is you knew how to do a common log, how to solve for one, but you didn't know what a log was. Um, you guys weren't understanding why you were doing it. And so today I want to cover why common logs work the way they work. Then we're going to finish up graphing today. Not introducing anything new. We're going to do a graphing review. Um, and I'll let you know when in the video we're starting that. If you feel really good about graphing, then you're fine to skip to the end, not take notes on the graphing section, and just do the homework problems. If graphing isn't your specialty, if you found that to be difficult, I would highly recommend watching the graphing section. But with that being said, I've been saying that way too much, by the way. With that being said, common logs. So you guys in class did solving logarithms. And just to be clear, I'm going to be checking for notes on logarithms. You're free to take notes on graphing, but I'm not going to be checking for the notes for those. If you're bad at them, I would highly recommend you do them anyway, though. So you guys did solving logarithms. And that was when you had log of a base of a number equals x. And then we said that was the same thing. That was the exact same thing as when you do b to the x equals a. Basically what happened here is your b stayed on the left, right? Both of them are on the left of the equals. And then instead of having an a with the b, you had an x with the b. And then on the other side of the equals, you flipped the side. So the way I look at it as you drop the b, right? The b stays here, and then you switch the sides. Your a and the x go to different sides. So we kept b, and then switched a and x. Nope, that's for later. So then we came into the question of what you guys were doing. How to use that to solve. Well, you have log base 2 x equals 3. Well, what I'd do is drop the 2. How do I do this? Drop the 2, and then switch the x and the 3 sides. So the 3 goes with the 2, and then the x goes on the other side. And what's 2 to the third power? 8. So 8 was x. All right. So let's talk about why. Why does that even work? Come on. All right, section 2. Okay. This is not working as well as I wanted it to. That's fine. Neither is this video. So what is a logarithm? What is a log? A logarithm is the power a number needs to be raised to in order to get another number. Think hard about that. A logarithm is the power a number needs to be raised to in order to get another number. In other words, what power would I have to raise 2 to get 8? That would be my logarithm. 3. 2 to the power of 3 gives me 8. What would 4 have to be raised to the power of to give me 16? 2. 4 to the 2 gives me 16. So 2 is my logarithm. Just a quick reminder, side note, if a log doesn't have a base, that means the base is 10. I don't know if you guys ever learned that in class, but it's the most important thing about logarithms in my opinion. So if I gave you just log of 100 equals 2, finish this, G. If I gave you log of 100 equals 2, that means that my logarithm is 2. That's how I'd read that. Log of 100 is 2. So what this question is really asking is, what would my base have to be raised to the power of to give me 100? And there's no base written here, so I'd have to write in 10. What power would 10 have to be raised to give me 100? The answer is 2. That's my logarithm. 10 must be raised to 2 to get 100. Let me do one more. What about log base 3, 27 equals 3? Well, what does 3 have to be raised to the power of to give me 27? 3. So that means that I need 3 must be raised to 3 to get 27. Let me do one more example, and this you'll have one in your homework like this. What if you had, I don't know, log base 5, 125 equals x? Well, what does 5 have to be raised to the power of to give me 125? One way to rewrite this would be 5 to the x equals 125, based on what we wrote at the beginning. Well, I know that 5 to the third power is 125. So x equals 3. Why? Because 5 must be raised 3 to get 125. For your homework problem, I want you to write your answer like that, okay? Tell me what the value is, tell me what the log is, and then explain it to me. So, that's literally all the notes I have for you today in math. Woo, short lesson. Let's do graphing review. Dadgummit, I'm gonna have to redraw all this because I already solved all of them. Nothing like re-recording what you've already recorded. Yeehaw. Okay. Linear equation. Y equals x plus 2. Let's do this quick. So, first off, XYT table. 1, 2, 3, 4. What's my vertex? Well, for a line, I don't have a vertex. I have a y-intercept. What is it? 2. Fantastic. So, where do I go from here? I plug in each of my numbers. Go down 2, up 2. Negative 2. If I plug that in, I get negative 2 plus 2. What's negative 2? 2 plus 2 is 4. What about negative 1? Negative 1 plus 2. That's 1 plus 2, that's 3. 1. What about negative 1 plus 2? 1. What about negative 2 plus 2? 0. Great. So what do I get? I have to go left 2, up 4, left 2, up 4, left 1, up 3, not left or right, up 2, over 1, up 1, and right 2, don't go up or down. I end up with a nifty little line from top to bottom. It looks like a curve. I meant to draw a straight line. Sorry, bad art skills. What are my transformations? What does that negative tell me? That tells me that I'm reflecting over the x-axis. What does this plus 2 tell me? That's my k, right? Remember? ax plus k is what we wrote this equation as, and k is a vertical shift. So I have a vertical shift up 2. Those are my 2 transformations. Now, when you have your take-home quiz tomorrow, this is how I'm going to want you to write it. I'm going to give you an equation. I'm going to want you to write the equation, draw the t-table, give me a graph, and then write the transformations. Quadratic. Y equals x plus 2 squared minus 3. That's supposed to be a minus. XY t-table. What's my vertex? Opposite of h, keep my k. What's the opposite of 2? Negative 2. Keep my k, negative 3. I'm going to go down 2, negative 3, negative 4, and up 2, negative 1, 0. All right. Plugging these numbers in. What's negative 4 plus 2? Negative 2. What's negative 2 squared? 4. What's 4 minus 3? 1. Negative 3 plus 2. What's negative 3 plus 2? Negative 1. What's negative 1 squared? Positive 1. What's positive 1 minus 3? Negative 2. Now, quadratic equations are symmetrical. They go up at the same time and they go down at the same time, which means that these two going up are also going to be these two going up. I don't even have to solve them. 3, 2, 1, this is going to be 3, 2, 1. It's the same with quadratics and absolute values. you can use that trick. So let's draw my graph. Okay, left 4, up 1. Left 4, up 1. Left 3, up 2. Left 2, oh, I'm sorry. No, ignore this point. It's an evil point. Left 3, down 2. Left 3, down 2. Left 2, down 3. Left 1, down 2. Don't go left to right, up 1. And so I end up with a curve going out. Again, I'm bad at tracing, but that's my parabola. What are my transformations? Do I have a negative? Nope. Do I have a vertical shift or stretch? Nope. So I have plus 2, which is the opposite of plus 2. So my h is a horizontal shift, left 2. And my negative 3 is a vertical shift, down 3. And it looks like those are my only transformations. Let's do a cubic. Negative 2 times the quantity of x minus 1 cubed. Get my xyt table online. 1, 2, 3, 4. What's my vertex? The opposite of h. Negative 1, that turns into a positive 1. My k, I don't have one, so it's 0. All right, I'll go down 2. 1, 0, negative 1. 1, 2, 3. Now time to plug in my numbers. So for negative 1, I got negative 2 times negative 1 minus 1 cubed. What's negative 1 and negative 1 combined? Negative 2. And what's negative 2 cubed? Negative 8. So I have negative 8 times negative 2. That gives me positive 16. If I plug in a 0. Negative 2 times the quantity of 0 minus 3 cubed. What's 0 minus 1? I'm sorry, 0, I said 3. 0 minus 1 cubed. That's negative 1 cubed. Negative 1 times negative 1 times negative 1 gives me negative 1. Negative 2 times negative 1 gives me 3. All right, if I have a positive 2 in there, negative 2 times positive 2 minus 1 cubed. 2 minus 1 is 1. 1 cubed is 1. Negative 2 times 1 is negative 2. Negative 2 times 3 minus 1 cubed. 3 minus 1 is 2. 2 cubed is 8. So that's negative 2 times 8. That gives me negative 16. Alrighty. Cool. So left 1 up 16. Left 1 up somewhere way up here. Stay the same. Go up 3. Go over 1. Go right 2, down 2. And then go right 3, down 16 somewhere. There we go. There's my graph. It's really stretched out. Why? Let's look at my transformations. What's the negative mean? It's reflected over the x-axis. What's the 2 do? That's a vertical stretch by a factor of 2. What's the negative 1 mean? Well, the opposite of that's plus 1, so that's a horizontal shift right 1. Do I have a vertical shift? No, it does not look like I have a vertical shift. So there's my 3 transformations. Okie dokie. Now let's do an absolute value. We got a lot of these. No, I think we did square root functions first. Y equals the square root of x plus 1 plus 1. XYT table. I told you guys we only need a couple points for these because they're smaller. So what's my vertex? The opposite of h, plus 1 turns into negative 1. K turns into positive 1. We can't go down 2 for these, if you'll remember, because if we go down any more, we'll divide by 0. And we'll start getting into impossible territory and we'll get square root of a negative number, and you can't do that. So Thinking about my list of 0, 1, 4, 9, 16, what do I have right here? Negative 1 plus 1 gives me 0. So I have 0, so I can find 1. So what plus 1 gives me 1? Well, 0 plus 1 gives me 1. So if I plug in a 0, that'll be my first number. How would I get a 4? What plus 1 gives me 4? 3 plus 1. All right, just for kicks, I'll do the next one. What plus 1 gives me 9? 8 plus 1 gives me 9. So when I plug these in, I get the square root of 0 plus 1 plus 1. 0 plus 1 gives me 1. Square root of 1 is 1. 1 plus 1 is 2. If I do the square root of 3 plus 1 plus 1, 3 plus 1 is 4. The square root of 4 is 2. 2 plus 1 is 3. If I plug in my 8 here, the square root of 8 plus 1 plus 1, 8 plus 1 is 9. The square root of 9 is 3. 3 plus 1 is 4. Alrighty. Okay, so the first point is left 1, up 1. The second point is 0, up 2. The third point is right 3, up 3. The fourth point is over 8, up 4. I end up with this little guy. So what are my transformations here? The H, I have an H, I don't have a negative, and I don't have a vertical stretch or compression. So my 1, I do the opposite. So that's a horizontal shift left 1. And the K would be a vertical shift up 1. It looks like that's all I got. We're almost done, guys. We're almost done. So next I have my absolute value function. Where are you? I wrote you somewhere. There you are. All right. So next we have our absolute value function. Y equals negative x minus 2 minus 3. Let's do all the negatives. XYT table. What's my vertex? Opposite of HK. Opposite of negative 2 is positive 2. K has stayed the same as negative 3. So then I go down to 2, 1, 0, up to 2, 3, 4. So plug in these numbers in. 0. Negative absolute value of 0 minus 2 minus 3. What's 0 minus 2? Negative 2. So that's negative absolute value of negative 2 minus 3. What's the absolute value of negative 2? This turns into positive 2, so I end up with negative positive 2 minus 3. Negative positive 2 just gives me a negative 2, minus 3 would give me negative 5. This is going to be the part that's going to mess you guys up on these problems. Be careful with your negatives. If I plug in a 1, I get negative absolute value of 1 minus 2 minus 3. 1 minus 2 gives me negative 1 minus 3. The absolute value of negative 1 is positive 1, so my negative carries over. This turns into a positive 1 minus 3. Negative positive 1 is negative 3. Negative positive 1 gives me negative 1. Negative 1 minus 3 gives me negative 4. Luckily, in absolute value functions, it's just like quadratics. This is a mirror. So if it's 3, 4, 5, down here it's going to be 3, 4, 5. And I'm done. So graphing this, 0, negative 5, right 1 down 4, right 2 down 3, right 3 down 4, right 4 down 5. It's a V shape. Cool. What are my transformations here? The negative means I reflect over the x-axis. The negative 2 that's a horizontal shift, right 2. This K is a vertical shift, down 3. Hooray! I believe that's it. The only thing I got left would be a asymptote problem, which is also technically graphing. So if I had 3x over Let's say I had the fraction of negative 3x over 6x minus 12. How would I find my vertical asymptote and my horizontal asymptote? So the vertical asymptote is what number would make my denominator 0. So if I had 6x minus 12 equals 0, what would make it 0? I would end up with 6x equals 12. I would divide both sides by 6. X would have to equal 2 to get 0. Is that true? 6 times 2 is 12. 12 minus 12 is 0. Yes. So for my vertical asymptote, x cannot equal 2, because if it does, it divides by 0. Really, you could say x equals 2. I'm just putting that for effect. So x equals 2 is the asymptote, but x cannot equal 2 is the rule. Kind of janky, but put this one. Don't put this one. So horizontal asymptote. I told you guys that you look at the coefficients of the x's, you make them into a fraction. So the coefficients of the x's would be negative 3 over 6, or 3 over negative 6, it doesn't matter. That simplified gives you negative 1/2. That's my horizontal asymptote. Okie doke. Sound like a plan? Well, here's your homework. Where did I put the paper? Where did I put the paper? Here it is. Okay. 1, 2, 3, 4, 5, 6, 7 problems. I want you to do exactly what I just did. Okay? A linear, a quadratic, a cubic, a square root, an absolute value, a rational, and vertical asymptote, horizontal asymptote. That's what I'm looking for. And one log problem explaining to me what is your x and y. That is that. Please ask me any questions you have, but as now we've hit 22 minutes, let's call it quits. Have a great day. I'm praying for all you guys.